Hello, welcome to Learning Beyond. We have already started our 2A slab analysis concept sessions. Till now, we have finished this, what is meant by 2A slab, then boundary conditions of 2A slab, and moment coefficients as per IS 456. Now, today we will see the practical structural drawings and how to apply these boundary conditions, how to understand whether there is a continuous support or discontinuous support in 2A slab. So in that, before going ahead for the practical problem, we will just clear certain concepts regarding this. Yes. So if you see this, let's say this is a slab, continuous slab, which is supported on these beams. So these beams are nothing but the supports. And if you draw the loading diagram, it will look like this. So these arrows means these are the beams which are supports. And this is a slab and there is a loading on that. Now, by looking at this image, you can see that there is no slab in the left side. Whenever there is no slab to the left side, in this case, then it will be discontinuous edge. So I can say that this is a discontinuous edge. Then if you see here for this slab, there is a slab on the right side. That means it is a continuous edge. Again, there is a continuity over here, continuous, then again continuous. This slab, there is no slab to the right side. That means it is a discontinuous edge. Once you understand this, then we can draw the bending moment diagrams. And as it is a discontinuous, it is a zero moment that is simply supported. Then we will have a continuity moment here like this. So this is in general the, we can say, bending moment diagram for the continuous slabs. Okay. Now we will see the next example. Now see, in many times practically there are possibility that there are sunk slabs. So the sunk slabs are there in toilets, bathroom, or terraces or balconies. So in that case, the slab is not at same level, but it is sunk below the floor level. Now, if you consider this case, the loading diagram is same because these are the beams and the slab is supported on the beams. But in this case, you can see there is no continuity here of the slab. That means this edge is discontinuous. This edge is also discontinuous because there is no slab. So it is a discontinuous edge. Here also there is no slab on the right side actually in this level. So it is also discontinuous edge. Again, same here. It is discontinuous. Now it is a continuous here because there are slabs on both the sides and they are at the same level. So this is a continuous and again this is discontinuous. If you draw the bending moment diagram, then it should look like this. Both are discontinuous means simply supported like this, zero moment at the supports. This is also discontinuous. Both are discontinuous. Now in this case, we will have this is a discontinuous and this is a continuous. So the moment diagram will be like this. So these are the boundary conditions, discontinuous, discontinuous, and this one is continuous. Similarly, in next example, philosophy is same. This is a discontinuous edge, no slab here. Then this is also discontinuous edge because there is no slab to this side. Then again, yes, it is a continuous, continuous, and this is discontinuous. The moment diagram will be like this. Then it will be like this. Yes. So this is the overall concept regarding the continuity and discontinuity. Now we will see the practical problem. So that how to identify the boundary condition as per IS 456 Annex D. So in that table, actually, we can see that we have seen that in our other videos. You can refer the other videos for understanding these concepts. Now, this is a practical problem. One residential building is there, RCC building, and there are slabs. You can see there are slabs, then beams are there, columns are there, staircase, lift, and all these things. Now, in this session, we are interested in understanding the boundary conditions of the two-way slabs as per IS 456. So to understand whether it is a discontinuous or continuous. So we have seen in the last session that these thick line colors are continuous edges and this thin line is a discontinuous edge. You can see here. And as per the continuous and discontinuous edge, there are cases given in the IS 456 two-way slab. That means case number 1 is interior panel. Then case number 2 is one edge discontinuous. If you see this case number 2, this is the discontinuous edge. Okay, one short edge discontinuous, and all other these 3 cases are continuous. So in this way, we can define the boundary conditions. Now in this problem, how to identify that? So which case is suitable for this slab? Let's see this first. So if you see here, there is no slab over here. So it is clear that it is a discontinuous edge. So for the time being, let's show the discontinuous edge using, let's say, blue color. So this is a discontinuous edge. So this is discontinuous edge, blue color, let's say. Then if you see this slab, there is no slab to the left side. So again, that will be discontinuous. So this is also your discontinuous edge, blue color. Okay. Now here, if you see this edge, there is a slab over here. And the spanning is also in this direction. So that means I can consider this as a continuous edge. Let's show the continuous edge with red color. So this is your continuous edge. Now, if you see here, this side, these beams, there is a sunk over here. Actually, these are toilet and bathroom sunk. And we know that when there is a sunk, there is no continuity of this slab. So I can consider this as a discontinuous edge. So if you see, this is a discontinuous. Okay. So the blue colors are discontinuous and red is continuous. And this is a short span and this is long span. Okay. Now, if you know the boundary conditions are defined over here. Now check which condition is suitable for this. So in that case, we can say, if you look here, that means there are 3 edges discontinuous and one short edge is continuous. So where is the case? So if you look here, only one short edge is continuous. So this is short edge, which is continuous, and all other 3 edges are discontinuous. So case number 8. So 8 is the case number here. Right. Check it out again. This is a short edge, which is a continuous edge. All 3 edges are discontinuous. So 8 number is the case for this. Similarly here, because they are symmetric. So you can see these are discontinuous edges and this is a continuous. So here also we will have a 8 number case, right? Now let's see the next slab. Take this example for this slab. Now this edge is discontinuous. This edge is also discontinuous because there is no slab. There is a slab here, but this is partially. So in that case, we can assume this as a discontinuous. So let's say this is discontinuous. Let's show that by blue color. Okay. Discontinuous. Then again, this one is discontinuous. Here also you can see there is a sunk here. So it is also discontinuous. And here also there is a sunk. So it will be again discontinuous. So all edges are discontinuous in this case. So it is, we can say, simply supported slab on all edges. So that means simply supported means you can see 9 number is the case, right? So 9 will be the case for this problem or for this slab, right? This is the 9 number case. Now let's see this slab. So there is a sunk. So it is discontinuous over here. Then yes, if you see here, there is a staircase here, and all of you know that staircase, the slab is not at one level, it is a sloping slab. That means you can say this edge is discontinuous edge because there is a staircase over here. There are partially we can say slabs over here, but when it is a partial case, we can assume as a discontinuous. So this will be again discontinuous. Okay. Then yeah, here you can say there is a slab over here at one level, and this I can assume as a continuous edge. So this is your continuous edge. Let's show in blue color or red color. So this is your continuous edge. And here there is a sunk and there is a duct, but that means there is no slab over here. So it is a discontinuous. So again, we know that this is a short. So this is similar to 8 case. You can see here, short edge is continuous, other are discontinuous. So it will be case number 8. Now this is a sunk. You know that there is a discontinuity over here already we have mentioned. It is also discontinuous. Again discontinuous here because there is a slab over staircase over here, and there is no slab here, so it is also discontinuous. So this is simple case, which is nothing but all edges are discontinuous. 9 number case. So this is your 9 number case. Okay, now let's take one other example. Yes, let's take this slab. Say all other are symmetric, so this will be again 8. This will be 9, because many times in residential buildings we have flats which are mirrored or similar flats are there actually. Now let's take this example. In this example, let's say this is your short edge and this is your long edge. So you see, short and long edge is important to understand. Even in this picture, this is a short and this is a long edge. And the conditions are based on that. Now, if you consider this slab, then you can see that there is no slab here. So it is a discontinuous edge. Then here to the left side, there is a slab, but partially slab is there. And again, partially sunk slab is there. So in that case, I generally prefer to have a discontinuous edge. If it is a partially continuous and partially discontinuous, because this is a sunk. So within this zone, the slab is not having continuity. So better we assume this as a discontinuous. Now in this case, there is a slab over here. That means I can say this is a continuous. So let's say continuous. And here also there is a slab here, and slab is at one level. So it is a continuous. So if you look at this, then you can understand the long edge is continuous and this short edge is continuous. So one long edge and one short edge is. So if you see in this panel, so which is the better in this? So one short and one long edge is continuous, and these are, so 4 is the case. It's very easy. One long edge and one short edge. 4, one short edge, one long edge, right? So this is the way we can understand the boundary conditions of slabs in practical problems. So we will see some other examples also in next session. So till then, goodbye and thank you all.